Hello and welcome to a Mr. Mario Maths video. Today we're going through question 1 of a Decision 1 Assessment 7 for Leeds Maths School. So in this question, part A, we're asked to define the terms tree and minimum spanning tree. And I've gone ahead and written down two definitions already. So a tree is a connected graph with no cycles. You need to include both the terms connected and no cycles in order to get the first independent accuracy mark. You can't use the word circle or loop instead of cycle, it has to be the word cycle. A minimum spanning tree is a tree that contains all vertices. The total length of its arcs is as small as possible. For the first independent accuracy mark, you need to say that it's a tree that contains all vertices. And then for the second independent accuracy mark, you need to mention the length of arcs being as small as possible. You need to contain all three of those points. Okay. Moving on to part B, and we're asked to use Kruskal's algorithm to find the minimum spanning tree for the network shown in figure 1. We must clearly show the order in which we consider the edges. For each edge, we're asked to state whether or not we are including it in the minimum spanning tree. And I'm going to go ahead and maximise my screen just so we can see all of these edges already written down. And I've also included the answer template for this question. I've already sorted my edges from smallest weight to largest weight, and as I go through this, every time I check an edge, if I were to write down this list again, I would scribble down and cross out the weight on the graph to make sure that I'm always getting the smallest one. So I would go FJ11 and cross that out, look for the next smallest one, and that's EG13, cross that out, looking for the next smallest EF15, and so on. Do that in pencil and you can rub it out if you need to. But now we're going to perform Kruskal's algorithm. We're going to add edges onto our minimum spanning tree unless we create a cycle. So can I add FJ to my minimum spanning tree? Yes, I can. So I'm actually going to add it to my minimum spanning tree for part C as well. This is going to help me do both parts in one go. So I'm going to add FJ11. Can I add EG13? Yes, I can. So I'm going to add it. 13, there we go. And I'm going to tick it on the list. Can I add EF15? Well, it's not going to create a cycle if I add it, so I can. So I'm going to add it onto my diagram. If I add EH, that's not going to give me a cycle, so I can add EH17. Can I add GH? Well, if I added the edge GH, I'm creating the cycle EGHE. So I can't add GH. Can I add BC? Yes, I can. That's not giving me a cycle. Can I add the edge HJ? No, I can't, because that's going to give me a cycle. Can I add the edge BD? Yes, I can. That's not going to give me a cycle. So I can add BD22. Can I add the edge FH? No, I can't. That's going to give me a cycle. I'm going to cross that one out. Can I add the edge AE? Yes, I can. That's not going to give me a cycle. I'm just going to avoid my 22 there. AE25. And I'm going to tick it to show that I've accepted it. Can I add the edge BE? Yes, I can. That's not going to give me a cycle. It's connecting two different parts of my tree, and it's making sure that my tree is therefore connected. So BE29. And I'm going to give that a tick. Note how my tree or my graph has 9 vertices and I've added 8 edges. This is always property of a minimum spanning tree. The number of edges in a minimum spanning tree is 1 less than the number of vertices. So I can say that I'm done now, which means that I'm automatically going to reject the rest of the edges. There we go. So I think I've answered part B. Have I answered part C fully? Have I drawn a minimum spanning tree? Yes, I have. Have I stated the weight of a minimum spanning tree? No, I haven't. So I do have to do that part. And to state the weight of a minimum spanning tree, I just need to add up these numbers that I've listed. And if I do that, I'm going to get the answer 151. Okay. So where do these marks come from? So looking at the mark scheme, I've got a method mark and 2 accuracy marks for part B. The first method mark comes after the first 4 edges being added correctly, and at least 1 rejection being seen. So it comes from going up to GH. The second accuracy mark, or the first accuracy mark, the second mark in this question, comes from if all arcs in the tree are selected correctly in the correct order, with no additional arcs included in the minimum spanning tree. So up to this part here, I get an accuracy mark, and then I get another accuracy mark for doing all rejections correctly and at the correct time. So I get a last accuracy mark if I rejected FH, HJ, and GH at the correct appropriate time. So I'm going to add that accuracy mark there as well. For part C, I get 1 independent accuracy mark for getting the correct minimum spanning tree only. There's no follow-through marks here. And I get an independent accuracy mark for getting the correct weight. Again, there's no follow-through marks. So that marks the end of this question. So I will see you in the next video. Have a good day and goodbye.